So the first problem we're going to look at is log base b of 81. So we want to look at 81 and we want to look at the known arguments of 2 or 3 and say, can I multiply 2 and 3 to equal 81? Can I divide 2 divided by 3 to get 81? Can I take 2 to some power to equal 81? Can I take 3 to some power to equal 81? And of those, yes, I could take 3 to some power to equal 81. And so that's my game plan on this problem. The first thing I'm going to do is rewrite that 81 as 3 to the 4th power. That's step 1. Rewrite it. Step 2 is to use the property of logs that applies. I cannot plug in this value yet because I don't have log base b of 3. I still have log base b of 81. But if I use that property of logs that says go ahead and put that exponent in front as a coefficient, now all of a sudden I have log base b of 3 right here. I know that log base b of 3 means the same thing as 0.68. So that means I can rewrite this as 0.68. Now is when I can get my calculator involved and say 4 times 0.68. Oops, I didn't say times, I did a dot there. Let me try that again. 4 times 0.68 is 2.72. And that's my answer to that particular problem. So as I look at my second example, I again want to say, is it 2 times 3, 2 divided by 3, 2 to a power, or 3 to a power to get 6? And hopefully it's clear that, yeah, the 2 times works really well here. So I'm going to start off by rewriting this as 2 times 3. Now again, I can't do a substitution yet because I don't have log base b of 2 and I don't have log base b of 3. I have log base b of 2 times 3. So I need to use a property of logs to rewrite this as log base b of 2 plus log base b of 3. Now I can do a substitution. Log base b of 2 is 0.43. Log base b of 3 is 0.68. And now I can bring my calculator into the mix. So now I can say 0.43 plus 0.68. When I add those together, I get 1.11. And that's my answer to that problem. So again, if you don't use a property of logs, you didn't do this problem right. You have to use a property of logs to get down to an answer here. Now for this last one, there's a 2 involved, but there's also a square root. But if we go back, I talked about this for advice earlier. Anytime we have a radical, try to rewrite that radical as a power. Since this whole logarithm business is all about undoing powers, it makes sense to rewrite that square root as the 1/2 power. Now we can use that power rule to bring that 1/2 out in front. And then we can do the substitution that log base b of 2 was 0.43, half of which is 0.215. And so that's the answer for log base b of square root 2, given those initial values that we have.